This video contains the solutions to the cross products practice problems handout. For these first couple of problems, we're just computing cross products. So the idea is that we create a determinant where we have I, j, and k in the first row. We have the first vector, which in this case is 3, 5, 0, in the second row, and the second vector, 0, 3, negative 6, in the third row. And remember that that's just fancy notation for taking a bunch of 2 by 2 determinants times I minus a 2 by 2 determinant times j plus a 2 by 2 determinant times k. So for the I determinant, we imagine blotting out the I column and just looking at the numbers that remain. So in this case, that's going to be 5, 0, 3, negative 6. And then we have a minus sign, then we blot out the j column, which leaves us with 3, 0, 0, negative 6. And then finally for the k column, that leaves us with 3, 5, 0, 3. And then again, that's just fancy notation for a difference of two products. So we take the 5 times the negative 6 minus 0 times 3. That's going to be our I component. And then remember the parentheses here, 3 times negative 6 minus 0 times 0. That gives us the j component. And then finally plus 3 times 3 minus 5 times 0. That gives us the k component. So doing arithmetic, that gives us negative 30i minus 18j plus 9k. So in other words, negative 30i plus 18j plus 9k, or written in vector notation, negative 30, 18, 9. And that's the result. We're going to do this next one the same exact way. Again, set up our 3 by 3 determinant, I, j, k, then write the first vector, 1, 6, 0, and then the second vector, negative 2, 5, 0. Work this out, we get 6, 0, 5, 0, I minus 1, 0, negative 2, 0, j plus 1, 6, negative 2, 5, k. That's 6 times 0 minus 0 times 5, I, minus 1 times 0 minus 0 times negative 2, j, and then plus 1 times 5 minus 6 times negative 2, k. That gives us 0i plus 0j plus 17k, and that's our answer, or we can write it in this form, 0, 0, 17. All right, for this problem, we're given two vectors, and they give us the vectors in ijk notation, but I'll probably convert that to the angle bracket notation in just a second. But we're asking for the area of a parallelogram. And so what we know is that the magnitude of the vector u cross v is just the magnitude of u times the magnitude of v times the sine of the angle between those two vectors. And it's also the area of this parallelogram. So that means that we're going to compute the cross product, and then we just need to find the magnitude of that cross product vector. So first things first, u cross v is, once again, our 3 by 3 determinant. So 3, 4, minus 1, and then 0, 5, 2. Working this out just like we did in the previous ones, this works out to be 13, negative 6, 15. And so then the magnitude of u cross v is just going to be the square root of 13 squared plus negative 6 squared plus 15 squared. And again, just doing the arithmetic there, that works out to be 430. So the square root of 430 is the area of that parallelogram. Similar question here, but now we're given 3 points and asked to find the area of the triangle. So first things first, if we have two vectors and we wanted to know the area of the triangle that has two of those vectors as two of its sides, so if this is the area that we're looking for, then what you should notice is that if we created the parallelogram, if we just shift the two vectors around to create that parallelogram, the triangle is exactly half of the area of that parallelogram. So if I had u and v here, the area of the triangle is just half of the magnitude of u cross v. But we don't have vectors here. What we have are points. And so if we have 3 points, A, B, and C, then the vector that we want is the vector from A to B. And the vector AB is just going to be the difference between the coordinates of those points. So the vector AB is going to be -4 minus 0, and then 1 minus 1, and then 0 minus 2. So that's going to be the vector -4, 0, -2. And then AC is again going to be the vector given by the difference between the coordinates. So that's going to be -4 minus 0, 3 minus 1, and 0 minus -2. So that gives us -4, 2, -2. So those are the u and the v that I'm going to use to find my cross product. So again, we set it up the same way, u cross v, I, j, k, first vector in the first row, second vector in the next row, and then again, working that out just like we did in the first couple of examples, this time it's going to be 4, 0, -8. So the area of the triangle is going to be half of the magnitude of that vector 4, 0, -8. That works out to be the square root of 80, and so our answer is that it's the square root of 80 divided by 2. So finally we have a word problem here about torque. And the idea here is that if we have a bolt, and we've got a wrench around the bolt, excuse my crummy artwork here, but the idea is that as we twist the wrench in a counterclockwise direction, this creates a torque that goes up. So the torque is a value that we represent with the Greek letter tau, and then we have two vectors here. We have r, which is the vector that represents the length of the wrench, and then we have F, which is the force acting on the wrench that creates the torque. So when we figure out what this torque is, the torque vector, we get r cross F. But we're just being asked here about the magnitude of the torque vector. And so the magnitude of the torque vector is going to be the magnitude of r times the magnitude of F times the sine of the angle between them. And in this case, we know all of those values. The r, that's just the length of r, that's just the length of the wrench. The magnitude of the force is given to us as 20 newtons, and then the sine of the angle between them, that's given to us as a 45-degree angle. So that's 0.25 times 20, which is 5, and then the sine of 45 degrees is the square root of 2 over 2, and that works out to be 5 radical 2 over 2. In this case, that would be our final answer.